Oh, hi there. Thanks for showing up for your learning and for your desire to learn to find the distance between 2 points on paper fluently and in your head. I salute you. So for this one, we're really going to be building our abilities to work with the Pythagorean theorem and to knowledge of our squares, as well as working with square roots in our head. So this is going to be something that demystifies a lot of math for you when you build these abilities. I enjoy building these abilities. I don't claim a very high level, but together let's practice. We're going to need some random numbers. I like using numbers between 2 and 12 for my practice. You want bigger numbers? Roll bigger dice. Roll more dice. You want smaller numbers? Roll a single die. You do you. Okay, so now I've got 4. There, 3 plus 1. 5 plus 1 is 6. 4 plus 1 is 5. And 5 plus 4 is 9. And I can choose to make any of these positive or negative. So let's make that negative and call it a day. Okay, first step is I'm going to go ahead and visualize this on the Cartesian plane. So 4, 6 is somewhere up there. 5, negative 9 is somewhere down here. Let's call it there. So that's 5, negative 9. These points are almost on top of one another. 4, 6. So the next thing that I'm going to do is figure out the Pythagorean right angled triangle that I can draw here and figure out the lengths of the legs. It's basically your rise and run. So here my rise is 15 and my run is 1. And I'm not concerned with signs because positive and negative, they're all going to become positive when we square them. So then we have the equation for the distance between these 2 points is going to be the square root of the rise squared plus the run squared. And we'll like to be able to do that quickly in our heads. So if you can find that d here is equal to the square root of 226, you're good. And so this is ever so slightly bigger than 15. So now another layer that you can add is like just estimate. I think this is going to be 15.04. That's my guess. Let's see how close I am. All right, so then we can test and see how close we are in Desmos. Not over here. In Desmos, which I have open over here. So if I, no, cancel, I would like to stay there, thanks. So I have the SQRT of 226, and it tells me it's 15.03. So my guess is pretty good, but maybe I can build my intuition and guess a little better next time. All right, so that's pretty well lit. How do you guess these? Well, I'll show you with a different example. Let's roll some more dice. And we'll try something with a little bit bigger run and rise. So this is a 4, this is a 9, this is a 7, and this is a 10. So let's put these ones negative and these ones positive. So now let's put that on in green, let's say. So negative 4, negative 9 is down here. So visualize these. And then the point that we're going to, 7, 10, is up there, let's say. So this is our hypotenuse. And I can't stand that either. So let's draw a better hypotenuse. That's much better. All right, and then we're going to investigate this right angle triangle here, which has a rise of 19 and a run of 11. Okay, so now we know that the distance between that is going to be the square root of 19 squared plus 11 squared, which happens to be 361 plus 121, which again happens to be 482, the square root of that. So now, 482 is a tricky number, and what we're going to do is we're going to look at what squares that happens to be between. And so we're going to be particularly interested in putting that on the number line, like between two other squares. I happen to know that's bigger than 441. So this is way bigger than 21, because the square root of 441 is 21. What about 22 squared? 22 squared is 484. 484. So it's ever so slightly smaller than 484, and 22 is the square root of 484. So I predict the square root of 482 to be equal to 21.9. Yeah, 21.9 what? 21.92. That's my guess. So let's check it. No, stay there. I want the SQRT of 482, 21.95. Oh, I was way off. Well, this was way too small. It should be 300ths bigger. So anyway, it's going to build your ability to recognize some squares up to a high level. You'll want to know things, like you will develop your knowledge of things like 22 squared being 484, 21 squared being 441. This is the way to build that knowledge, like knowledge of your squares up to a large number. And well, they're not even that large. So for showing up for your learning and for learning to find the distance between 2 points in your head or on paper efficiently, I salute you. Oh, and if you want more challenge, of course, throw one of these on a fraction. Actually, I better show that level, and I'll do it on paper for sure. Give me one moment, I'll get us set up. All right, let's do a harder one here. So I've rolled some random dice. I made one fraction, and let's see how that changes things. So it doesn't change it an awful lot. It's just going to build your ability to work with fractions very effectively. So -7/4 is just ever so slightly smaller than 2, and 9 is up there big. So that could be the point. -7/4, 9. Okay. And then 7 is over there, and -8 is down there, so that's something like there. -7, 8. And then we're going to investigate this triangle again. And so we find our rise, and our rise is, oh, that's 7, not -7, 7, -8. Okay, so our rise is -17. But again, we're just interested in the positive number. And so we have the distance is going to be equal to the square root of, well, what's this one? Well, this one has a fraction in it. It's going to be 7/4 plus 7. So that is the same thing as 8 3/4. 8 3/4 is the same thing as 35/4. 35/4. Okay, that's our run. All right, how do we do that? Well, we're going to have 7/4 plus 7. So doing it visually avoids you having to do things like 7 minus -7/4. But if you wanted to do it that way, that would be fine. This is 28/4 plus 7/4, which is the same thing as 35/4. Okay, good. So now we know that D is equal to 35/4 squared plus 17 squared. -17 squared, 17 squared, same thing. So D is equal to the square root of 35/4 squared. Well, that's going to be 35/4 times 35/4 plus 289. Wait, no, that's not 289. It is. Yeah, it is indeed 289. So 17 squared is 289. I don't know why I balked at that. And then anyway, 35 squared. Well, that's nasty. I happen to know it's 49 times 25. So 49 times 25. 1,225. 1,225. But here's another way to do 35 times 35. Okay. Visualize them as areas. So you have 30 times 5, 30 times 5. So that's 30 plus 5 times 30 plus 5. It's a rectangle, but in this case it's a square because I'm just squaring things. This little bit of area there is going to be 900. 30 times 5 is 3. This is 150. Getting ahead of myself. This is 150. And then 25. So 5 times 5 is 25. Okay, let me just add all those up. And that gives me 1225, which I got a different way. Okay, I'll show you the way I did it because maybe you like these tricks. 35 squared is the same thing as 5 times 7 squared, which is equal to 5 squared times 7 squared. And I can work that out a little better than I can this. So I decided to do it that way. 25 times 49, well, that's the same thing as 25 times 40 plus 9. And this is 1,000. This is 225. So that's another way of doing that. And what else to say about it? Oh, right. So that's 1225. So now we know that the D is equal to 1225 on top of 16 because we have to multiply these as well. Plus, well, we better put 289 on top of 16, shouldn't we? So that would be 289 times 10 plus 6. And so that's 2,890 plus that's 1,200. I believe. Okay, let me just check. That's 1,200. 480. Yeah, I got it. So then you add those together, and that gives you 4 back there, 2 there, 6, 4624 on 16. Okay, that is to say 289 is equal to 4624 on 16. Adding those together, D is equal to the square root of 1225 plus 4624. Which gives us 5, 8. There's no carry here, so it's not bad. 4, 9 on 16. Now that is tricky to work out in your head. But I know that when I take the square root of this, I'm going to have something on 4, because 16 is a perfect square. So when I take its square root, I get 4 in the denominator. So now I can do the square root of 5849, put that result on 4, and get my estimate. So geez, squares up to like close to 6,000, eh? So what would that be? Closest one, well, like it's below, between 70 and 80. So let's ballpark it at, it's right smack in the middle, like 75. Say it's about 75 on 4, which would make it a little bit bigger than 8. And I have an error. My gosh, it's so annoying. How do I have an error, or my estimate is way off. Oh no, it's not. It's not. No, it's good. It's good. So 75 on 4 is roughly the same thing as like 18 and a bit. And yeah, that feels right. This is about 18 and a bit. So now put it into Desmos, and you can put that into Desmos and see how close it is to your estimate. All right. So let's go Desmos. Make this smaller. We're going to clear these out. We know these facts. But we're going to check SQRT bracket 35 on 4, end the bracket, square the bracket, plus 17 squared. And we got, yeah, a little bit bigger than 18, I said. Which was slightly wrong. My estimate's slightly off, but still pretty good. So, awesome. And then we might want to just check our math and say, is that the same thing as SQRT of 5849 divided by 16? And that looks good. Yeah, they're the same. So we did it correct. All right. So I would be working on those on paper and not in my head. But if I wanted to go to a high level in math, I might want to get that skill where I can do this in my head with fractions. Okay, all the best, everyone, and congratulations on being someone that wants to build your math fluency to a high level. Bye for now.